Okay, so this is a pressure volume diagram. This is van der Waals equation of state, and this is the compressibility factor of a substance, usually a gas or a vapor. And so how to read this pressure volume diagram is, so you have isotherms and you have this dome. This dome is a phase line. It's like an equilibrium point. Anything underneath the dome does not exist. So what you have is isotherms like below critical temperature go through, hit this line, and then come out the other end, because in here it's like a liquid vapor pressure equilibrium, and above the critical temperature you have isotherms that just continue on, and because this is in the gaseous region, and then in between here, you have the vapor region where it's a liquid vapor balance. It's like, I think, um, a liquid that's about to condense. And then over here, it's like a liquid that is potentially going to boil. Or here, it's a liquid that's potentially going to boil. And you'll notice this is actually not that accurate. It's going to be something more like this, because you can't really, pressure does not really affect liquids that much. But so And notice here is the critical point where the dome and the isotherm meet. And we don't know the A and B parameters of the van der Waals equation of state, B being the excluded volume and A being the attractive forces of gas molecules, because no gas is ideal. And of course you're going to subtract the attractive forces because molecules are going to interact with each other no matter what. And how we can derive A and B, you'll notice as it approaches this point right here, the critical point, it starts to like flatten out. And that's useful because it tells us that here the derivative is equal to 0. So I can go ahead and derive this as, I'm just going to call it P prime is equal to RT over B minus B squared. I believe this will make it negative because it's under, and then plus A over plus 2A V cubed. And that is equal to 0. And another thing is, you'll notice this is concave up going to concave down. So it's also an inflection point, which means the second derivative is equal to 0. So P double prime is equal to 2RT over V minus B cubed minus 6A over V to the fourth is also equal to 0. And since these are equal to each other, you can just make it 2A over V cubed is equal to RT over V minus B squared, and then 6A over V fourth is equal to 2RT over V minus B cubed. And since these are going to be both equal to each other, they're all equal to 0, you can multiply them out to make it, let's see, I'm going to multiply this onto this one, so that way it's going to be, if you can follow the cancel it, can you see this? Okay, so if you can follow the canceling, so once you multiply the A across, A cancels, 2 cancels, this becomes 1 over 3. This becomes V, because this cancels out, or that, well, 4 cancels out. This cancels out. This all cancels out, so it's the RT cancels out, so it's V minus B over 2. And so what you're left with is V over 3 equals V minus B over 2. And from there, you have, I'm going to set B so it's times 2, so it's 2v 3 v minus b 2/3, and that becomes minus v, that becomes negative 1/3. V equals negative b, and so b is equal to v over 3. It's 1/3 v. I put the v in the wrong place. It's negative 1/3 v here. Okay, b is equal to v over 3. So we have that. And to solve for a, we can just plug that into the derivative and get negative RT. No, or actually, no, it's set equal to each other already. So it's RT over v minus v over 3 squared equals 2a over v cubed. So you have RT over, and once this is squared, this is 2/3 v. 2/3 squared, this is going to be 4/9. And since it's on the denominator, you're going to reverse it, so makes it 9 over 4. I'm going to let my cat in. Okay, so it's 9/4 RT over V. 9/4 RT over V squared. So I'm just going to replace that with V squared. And so we want to isolate A, so that way we multiply V cubed over. So it is V, so it's RTV, because the B on the bottom cancels out. And so we're left with, or we divide everything by 2, so that way it becomes 9/8. And so we're left with A is equal to 9/8 RTV. And to find the compressibility factor, we first want to just substitute everything into the equation that we found so far. So pressure is equal to RT over, this is going to be just 2/3 V, not just 2V over 3, because that's what that's going to be, minus 9 over 8 RT V over V squared. And then you have, well, okay, all these are going to be C's because it is critical, so criticals. And then it's this 2/3 here multiplies up to the top to be 3/2, so it's 3/2 RTC over VC minus 9/8, not 98, 9/8 RTC over VC, and this fraction comes out to be 3/8. Critical pressure is equal to 3/8 RTC over VC. So we want to convert to the critical compressibility, and to do that, we want to just multiply the pressure by, or both sides by V over RT, so that way it becomes Z is equal to well, see the RTV, that's all gonna cancel out, so Z is just equal to 3/8, and that's the compressibility factor theorized by van der Waals. I already started erasing, but I meant to add in that that's the compressibility at critical temperature of any substance theorized by van der Waals. Okay, I just had to add that.